You might have a pretty clear mental picture of what a planet is, but the official definition is surprisingly contentious. The shock demotion of Pluto from planet to dwarf planet in 2006 shows just how our understanding of celestial objects can change over time, especially as we continuously make new discoveries. Now, an astrophysicist from Johns Hopkins University has proposed a revision to the definition of a planet, to help differentiate gas giants from brown dwarfs. In 2005, the discovery of 3 large trans-Neptunian objects shook up our understanding of solar system bodies. These objects, now known as Eris, Haumea and Makemake, seemed to fit the definition of planets, but astronomers were concerned that classing them as such could open the floodgates for a whole range of asteroids and moons that technically fit the description too. With no official definition to refer to, the International Astronomical Union (IAU) set about outlining clear rules of what is or isn't a planet. In August 2006, the verdict was handed down. Officially, a solar system planet had to fulfill 3 criteria. It has to be in orbit around the Sun, it has to have sufficient mass to form a roughly spherical shape, and it has to have cleared its orbit of other objects. That conveniently rules out asteroids and other objects in the Kuiper belt, like Eris, Haumea, Makemake, and most famously, Pluto. However, that definition only applies to our solar system. The IAU hasn't yet decided how to officially define exoplanets, but a 2003 statement outlined a working definition that could change with future discoveries. Basically, a planet is an object that orbits a star, but has a mass smaller than the lower limit needed for thermonuclear reactions to kick into gear, which would turn it into a star. Some objects complicate matters though. Brown dwarfs occupy the weird space between planets and stars. These huge Jupiter-like objects have masses large enough for thermonuclear reactions to begin, but they never actually fire up, leading them to sometimes be called failed stars. From our vantage point on Earth, it can be hard to spot the difference between a massive planet and a lower-mass brown dwarf. The Johns Hopkins study aims to clarify the distinction between the two. To do so, astrophysicist Kevin Schlaufman examined 146 star systems, and found a few recurring details that could help draw the line. While we think we know how planets form in a big-picture sense, there's still a lot of detail we need to fill in, says Schlaufman. An upper boundary on the masses of planets is one of the most prominent details that was missing. Based on his observations, Schlaufman set that upper limit at 10 times the mass of Jupiter. But that number isn't just a neat figure to place the cutoff. It seems that objects larger than that form through different processes to smaller objects. Schlaufman found clues to these origin stories in the stars these objects orbit. Planets between 4 and 10 Jupiter masses were found to favor more iron-rich stars, which led to planet formation because of their higher levels of rock-producing elements. Brown dwarfs, on the other hand, didn't seem to have a preference, since they are usually formed from collapsing clouds of gas, in the same way as stars. Like the IAU's working definition, Schlaufman acknowledges that his definition is subject to change as future observations make more discoveries. The research was published in the Astrophysical Journal.